Hey guys, it's Jessie. This video is to help you with chapter 11. These examples came straight out of the part 2 exam, so know them and love them. A couple other things I want to point out. This table here in your book, table 11.7, is a really good conceptual kind of idea of how pH relates to both the concentration of your hydroxide ion, which is your basic ion, and the concentration of your hydronium or your acidic ion. Also, just on the opposite that page is the sample problem, which is a really good one. Go through this, and it talks about the dissociation constant of water. So whenever you have water, the total pH is going to add up to 14, but it's going to be a balance of hydroxide and hydronium, and they'll always be in equilibrium with each other. So if you have the concentration of this one, you know the concentration of this one because together it's 1 times 10 to the minus 14. Okay, let's do one of those. The example says, what is your concentration of hydroxide when your concentration of hydronium is, let's say, 1.7 times 10 to the minus 2 molar? Well, I know that together they equal 1 times 10 to the minus 14. So the concentration of hydroxide is equal to 1 times 10 to the minus 14 over 1.7 times 10 to the minus 2. Okay, I'm not going to put that in my calculator, so you guys can do that part. So let's talk about another good example. Again, I'm reading this from your part 2 exams, so there's no reason for you to be missing these when I'm giving you great examples. How many liters of 0.75 molar solution of hydrochloric acid will I need to completely titrate 1.4 liters of a 0.29 molar solution of NaOH? Well, the first thing I recognize here is that I'm going to be going between species, from one species to another. So I'm going to need to know what my balanced equation is. So I'm going to go ahead and sketch that out. HCl plus NaOH. And I know I'm neutralizing it. They said it's to titrate it, so I know I'm going to end up with water, right? I'm trying to neutralize that base. So H2O and salt. And it looks like it's a balanced equation as it is. So all my molar ratios are 1 to 1. So if I have 0.29 moles per liter of NaOH, and I have 1.4 liters of it, and for every 1 mole of NaOH, use 1 mole of HCl, which is a 0.75 mole per liter solution, then I have canceled out these liters and moles of NaOH. I am now in liters of HCl. So So all I have to put into my calculator is 0.29 times 1.4 divided by 0.575 is equal to liters of HCl. Okay, you guys? I want to see excellent grades on chapter 11. Reach out to me if you're doing your practice problems and having any questions, okay? Good luck.